Hello, Professor. This is Brian Coffin. We're going to start with the video for post-lab video reflection for Lab 3, Mod 3. We had two different experiments to do. The first one was over. Sorry, I've been doing so much today. Chemical formula for copper gluconate. Well, we had to determine it anyways. Interesting lab, to say the least. It was something I've never done before, creating copper out of two washers in the solution. The next was the chemical bonding, which was very interesting in itself to see what would melt first, the stearic acid or sodium chloride or the sugar. I honestly picked the stearic acid would not melt. Thought the salt and sugar would. So I believe I was completely steered wrong on that one, but we'll get to that. We'll get back to the experiments here in a minute. Safety-wise, I can't turn it around, but I can show you. There is my storage. Same thing over there I did for Lab 2 earlier today. It was, stainless steel sheet, fire extinguisher, trash, paper towel, bathroom and stuff is over there around the corner for the shower and for the another sink to use. So that is that aspect of it. So let's get into the results. For the first experiment, for the chemical formula, well, obviously we did the 1 gram of copper gluconate. That's what we weighed out to start with for the powder form. Then we mixed it, heated with the 2 washers in there. Obviously, I ended up heating it for, I believe it was 13 minutes and 46 seconds. Weighed the copper, dried it, weighed it on the weighing sheet, and it came back at 0.0 grams. I did not get any weight off of it. So I'm hoping that is correct. The next experiment we did was the chemical bonding. This one was kind of neat too. Said I haven't done stuff like this since high school. The sucrose, time it took to melt was 1 minute 11 seconds. Sodium chloride did not melt. Stearic acid 42 seconds. So that one went really quick. Stearic acid was first, sucrose was second, and sodium did not melt. Type of bond, sucrose was covalent, sodium ionic, and stearic was covalent. So it covers the results of it. For the calculation of the percent of composition and the molecular formula, we went with, or I should say I did, it's calculated from the molecular formula by dividing the mass of a single element in one mole of a compound by the mass of 1 mole of the entire compound. and this value is the percentage. So that's how I did that. To critical thinking, trying to identify two sources of error in each experiment and how each error could specifically impact your results. I honestly would use the first one for both. Having a constant temp, or I should say not having a constant temp, is a problem. Because it can fluctuate how long it takes, or it can be slow, it can be long, it may not. On the next one, it exceeded 20 minutes. Only if you exceed 20 minutes of heating the copper gluconate would that, I think it would have any effect, which we weren't supposed to exceed. The constant temp thing, wavering back and forth with the flame, it's just not constantly underneath of it. So the temperature does fluctuate a little bit. What module learning objectives did I struggle to achieve? Calculating the molar concentration, I did struggle with that. Had to do that several times. How do the activities this week connect to what we learned in the lecture? The biggest thing I learned from this week's activities are seeing like the covalent and the ionic bonds actually happening in front of me by doing the experiments with the melting and not melting. It's amazing how fast some things will melt, some won't, and some won't even melt at all. So this is my post for video number 3, lab 3. Hopefully I did everything correct, and I did take a picture of the copper on the way with the chart. I will email that to you, or I'll figure out how to get it to you. Thank you.